Alright guys, here we are. We're back at question 10. A cyclist, by the way guys, if I'm not doing mathematics on my spare time, I normally enjoy cycling. I've got a road bike. I do cycle a lot. Yeah, today I'm recording this with my daughter. Please don't mind the noise in the background. Let's read the question. It says here, the cyclist rode from town P and then stopped at town T. The speed in kilometers per hour at which this cyclist rode is represented below. So this is our formula here. As you can see, it's a derivative. It means they have derived this question from the distance. All right, let's go on and say they said that please note that the speed is the rate of change in distance with respect to time. All right, and those of you who are doing physics, I think you'll be familiar with this one, the rate of change in distance into time, which is what gives us this kilometers. Distance is in kilometers, into time it's in hours. All right, so let's do 10.1. 10.1 says calculate the maximum speed that the cyclist reached on this ride. All right, so now the speed maximum, I've already told you guys, every time you hear the word maximum or minimum and we're dealing with derivative or we're dealing with functions, you must just know that they want you to equate the derivative. They want it to be equal to 0. So in this case, they're asking us to calculate the maximum speed. So they've given us S, which is that. But however, guys, can you see that this is what? This represents the speed, okay? So this equation represents the speed, but however, we can't say that what are we looking for? We're looking for the maximum speed reached. So we need to get the maximum time. So what do you do now? We must take out the second derivative and equate it to 0. So second derivative, you're going to bring down the 2 here is going to be negative 3 times 2 into that, 2 minus 1, and then here we're going to have what? 18 is going to be t1 minus 1. So here is as good as, let me put it nicely here for those of you. Let me say times 1, t1 minus 1. So now we're going to simplify our derivative. In this case now is going to be equal to negative 6t plus 18. Okay, so this will have to be equal to 0. Okay, this is the same thing that you would do if you were doing, let me see, if you were doing a cubic function and they ask you for the maximum point of inflection. So this is what you would calculate. So this is the second derivative is equal to 0. So we are looking for the maximum, the time it took to reach that maximum speed. Okay, so negative 18, take 18 to the other side, gives us negative 18 divided by negative all over negative. There's cancel out. T is equal to, is going to be 3 hours. Okay, so this is the time it took to reach maximum speed. So therefore, after this, guys, we're gonna take this time, maximum time it took to reach maximum speed, to substitute it back into the original equation to find the original speed. So therefore it means S when t is equals to 3 is going to be negative 3 squared. We're substituting into the original equation of the speed is equals to 3. Now we're gonna go ahead and punch this into our calculator. Then we'll find out that maximum speed, which is reached at 3 hours, is going to give us 27 kilometers per hour. Okay, and this will be that our max speed. Okay, so this will be our maximum speed, guys. Right? Great stuff. So that's how you would deal with that one. So let's come here and say calculate 10 point. This is what 10.2. Calculate the distance between town P and town T. Okay, so now they are asking us to calculate the distance between town T and town P. So now it means if this cyclist started here at town P, they will ride their bicycle, ride their bicycle and reach point that they reached maximum speed, which is this maximum speed here, in what? In 3 seconds. In 3 hours rather, not 3 seconds. Okay, So now they want us to calculate the total overall distance. So now you need to calculate the total time it took for this cyclist to reach the end. So what can you do? What you can do in this case, it's either we can work out the total time, or the total traveling time, not the time it reached to reach maximum speed, but the total traveling time. So therefore this total time, we will get it when the speed is equal to 0. So it means this person starts here, and then the speed here is equal to 0, speed is equal to 0 here, and also the speed here is equal to 0. But we also understand that before this person starts riding, the time is also equal to 0. So it means there's also a time here when this person reached the destination. So this is what basically what we are looking for in this case. So we're gonna come here and say, okay, negative 3t squared plus 18t is equals to 0. So we're going to remove a common factor of t, in this case minus 3t plus what is going to be 9. Is it 9? Oh, sorry, excuse me. It's going to be plus 18 close bracket equals to 0. So t is equals to 0, or also negative t is equals to negative 18 divided by negative 3 divided by negative 3. T is equals to 6 hours. So this is our t total, guys. It's equals to 6 hours. This is the total time it took for the ride, total riding time, ne? Okay, so this is the total time for the ride. So now once you have this, we need to get the distance now. But remember, they said this is, please note, the speed is the rate of change in distance with time. Okay, so now with respect to time, so now we can derive this one backwards. Let's see, st we need to derive this one backwards, is equals to negative 3 t squared plus 18 plus t. So if we were to derive this backwards, we're going to have s, which is our distance. Then we're gonna multiply backwards, guys. So we're gonna take this one backwards, so it means this 3 is gonna come here. We're gonna add 1 there. It's gonna be negative. It's gonna be negative t. We add 1 here plus 18. No. This was 18. It was 9 times 2. So we're gonna take it backwards. It's gonna be 9t squared. Okay. So guys, with this you can see already. We can see already that what you have here. We can see already what you have here is, if you were to derive this, you'll go backwards here. Okay, so if you were to take this, okay, don't mind, that's my daughter, guys. She also wants to do mathematics, excuse me. All right, guys, so now welcome back. So now if you need to go backwards, it's gonna give us that. So now we already have what we see here as a distance. So the maximum time it took, so we're gonna substitute our t, which is this one here, we're gonna substitute it into this equation here. So we're going to have negative is gonna be 6 cubed plus 9 3 squared. This will give us the maximum distance, which is going to be 180 kilometers. So this cyclist really traveled 108 kilometers. That was the distance between two different towns. Have I ever done this distance before? Yes, of course, guys, I have done this distance before while cycling from where I stay to a different town. I am Gaston Mapala. Let me see you on the next question, where we'll be doing question 11.